The general solution of your transmission line. The transmission line is a conductive method of guiding electrical energy from one place to another place. A uniform transmission line of infinite length that contains infinite number of T section, each of infinitesimal size dx. The equivalent circuit of one T section is given here. It contains the component, the primary constant like R, L, G and C, and these components are called as distributed components because a element or component that is distributed over the entire length of the circuit means it are all called as a distributed component, since it cannot be measured at a single point of the circuit. And this T section having two ends. At one end the voltage and current are V and I. At the other end of the T section the voltage and currents are V plus dV and I plus dI. The series impedance of the T section is Z and it is equal to R plus J omega L, and the shunt admittance is Y equal to G plus J omega C. For the length of dx, the series impedance is Z equal to R plus J omega L into dx, and admittance is Y equal to G plus J omega C into dx. First, we have to calculate the potential difference between the 2 points of the T section. The potential difference or the voltage drop. The potential difference between the two ends of the T section is V plus dV minus V. Since at one end of the T section the potential is V plus dV and at another end the potential is V. So the potential difference between two ends of the T section is V plus dV minus V. Normally V equal to I into R. So this potential difference is equal to I into R plus J omega L over the length dx. By solving this, dV equal to I into R plus J omega L into dx. And from this, dV by dx equal to I into R plus J omega L. And R plus J omega L is nothing but the series impedance Z. Therefore, dV by dx equal to I into Z. Similarly, we have to calculate the current difference between the two ends of the T section, and this is due to the voltage drop across the admittance of the T section. The current at one end of the T section is I and another end of the T section is I plus dI. So the difference is I plus dI minus I, and this is equal to V into Y, that is V into G plus J omega C into dx. By solving this, di equal to V into G plus J omega C into dx. Therefore, di by dx equal to V into G plus J omega C. And this G plus J omega C is nothing but Y. So, di by dx equal to V into Y. dV by dx equal to I into Z. This is the first equation. di by dx equal to V into Y. This is the second equation. The next step, we have to differentiate the first equation with respect to x. So differentiating the first equation with respect to x gives d square v by dx square equal to r plus j omega l into di by dx. Since the first equation is dv by dx equal to r plus j omega l into I. So differentiating that with respect to x, it will become d square v by dx square equal to r plus j omega l into di by dx. Then we have to substitute the value of di by dx from the second equation. So the equation becomes d square v by dx square equal to r plus j omega l into g plus j omega c into v. Then differentiating the second equation with respect to x, it gives d square I by dx square equal to g plus j omega c into dv by dx. Then substituting the value of dv by dx the equation becomes d square I by dx square equal to dv by dx is I into r plus j omega l. So it becomes r plus j omega l into g plus j omega c into I. Then we have to substitute the value of the propagation constant gamma in equation 3 and 4. Since gamma equal to root of z into y, and that is equal to root of r plus j omega l into g plus j omega c. Therefore, gamma square equal to r plus j omega l into g plus j omega c. So the equation 3 becomes d square v by dx square equal to gamma square into v, and d square I by dx square equal to gamma square into I. So these two are the second order differential equations, and the solution of the equations are the equation becomes d square v by dx square minus gamma square v equal to 0. So the solution of the equation is v, and that is nothing but v equal to a into e power gamma x plus b into e power minus gamma x. Similarly, solving this equation, it becomes I equal to c into e power gamma x plus d into e power minus gamma x, where a, b, c and d are called as a arbitrary constant. Actually, we have to find this constant, then we replace the equations V and I to get the voltage and current equations of the transmission line. So to find the constant value, we differentiate the equation phi with respect to x. So dv by dx equal to a into, here it is e power gamma x. This term is varying with respect to x. So by differentiating this one, we get differentiating e power ax is nothing but a into e power ax. So this becomes gamma into e power gamma x. Then the next term is b e power minus gamma x. Differentiating this with respect to x becomes minus gamma into e power minus gamma x. So the equation is dv by dx equal to a into gamma e power gamma x minus b into gamma e power minus gamma x. Therefore, but we know that dv by dx equal to I into z from the first equation. So replacing here the value of dv by dx is I into z. The equation becomes I into z equal to a gamma e power gamma x minus b gamma e power minus gamma x. And this is equal to a into, replacing the value of gamma with the root zy, a into root zy into e power root zy into x minus b into root zy into e power minus root zy into x. And this is equal to a into, and the equation here is I into z. So bringing this z in right side, it will be root zy by z. So it becomes root of y by z, and a root y by z e power root zy into x minus b root y by z into e power minus root zy into x. So here we differentiate equation 5 with respect to x, and we substitute dv by dx equal to I into z from the equation 1, and we get the expression for I. Then the next step, we have to differentiate equation 6 with respect to x. So differentiating 6 with respect to x, it becomes di by dx equal to c into gamma e power gamma x minus d into gamma e power minus gamma x. But we know that di by dx equal to v into y. So using this, di by dx is replaced by v into y, that is equal to c gamma e power gamma x minus d gamma e power minus gamma x. And replacing the value of gamma by root zy, this becomes c root zy e power root zy into x minus d root zy into e power minus root zy into x. And bringing this y in right side, the equation is for v equal to c root of z by y e power root z by into x minus d root z by y into e power minus root z y into x. This is equation number 8. And the distance x is measured from the receiving end of the transmission line. We consider the receiving end at x equal to 0. So at the receiving end, the current I is written as receiving end current IR, and the voltage V is written as the receiving end voltage VR. And V is nothing but generally V equal to I into R according to Ohm's law. So the VR is written as IR into ZR. Now we have to replace the value of I and V from equation 8, 7, 6 and 5 by I equal to IR and V equal to VR. So the equation 5 becomes VR equal to A plus B, and equation 6 is IR equal to C plus D. Since in equation 5 we have to substitute x equal to 0. The equation 5 is v equal to a into e power gamma x plus b into e power minus gamma x. By substituting x equal to 0, the e power term becomes e power 0 and the value is 1. So it is a into 1. Therefore V are equal to A. A into 1 is A. The next term is B into e power minus gamma x. And x equal to 0 means the e power minus 0 also 1. So 1 into B equal to B. Therefore, VR becomes A plus B. So, substituting the value of x equal to 0 in equation 5, 6, 7 and 8, we get the equations 9, 10, 11 and 12. And we have to use V equal to VR and I equal to IR. Then by solving these equations, we have to find the value of A, B, C and D. Let x equal to root of z by y. We consider x equal to root z by y. Therefore, 1 by x becomes the reciprocal of x, that is root of y by z. And from equation 11, IR equal to a by x minus b by x. Because here we have 1 by x is root of y by z. So replacing root y by z by 1 by x, IR becomes a by x. IR becomes a by x minus b by x. Taking 1 by x outside, this becomes 1 by x into a minus b. And IR equal to, but IR we know that from equation 10 IR is C plus D. So we replace IR by C plus D. Therefore the equation becomes C plus D equal to 1 by x into A minus B. Multiplying x in left side of the equation, this becomes Cx plus Dx equal to A minus B. Therefore A minus B equal to Cx plus Dx. This is equation number 13. Then we have to take for VR. VR equal to C into root of Z by Y minus D into root Z by Y. We have to replace root Z by Y as X. Then we get the expression for VR, and we have to equate this value with the equation 9 since it is also the expression for VR. So we have to equate A plus B equal to C into X minus D into X.